Imagine Learning Twig Science, we believe all teachers and students deserve high-quality, research and evidence-based instructional resources that support all learners to make sense of their world. In this video, we'll showcase how Twig Science focuses on sense-making and develops grade-level cross-cutting concepts and science and engineering practices. We'll also highlight how Twig Science supports diverse learners and leverages prior student ideas and experiences as an asset for science learning. Let's take a deeper dive into Grade 4, Module 4, Earthquake Engineering. Key progression resources for each grade can be found online, such as the progression documents, visual kit lists, and the phenomena tracker. Students make sense of the anchor phenomenon by taking on the role of engineers. They investigate how waves influence earthquakes, the impact of forces on materials, and design solutions to reduce the damage caused by earthquakes. To begin with, students investigate how are waves involved in earthquakes. They engage with science and engineering practice, or SEP, too, as they develop models to describe the waves caused by earthquakes. They develop a grade-level understanding of CCC1 as they observe similarities and differences in wave patterns, and work towards CCC5 as they figure out that waves transfer energy.
All right, guys, I'm gonna drop this rock in, so I want you to pay close attention to what happens in the water. I want you guys to trade books, and we're gonna be looking to see which model best represents the waves that we observed in our demonstration. How did Carson show the waves, the ripples in the water?
He made like some curving lines, and he put a circle in the middle, like I think to kind of show the splash, like where the rock landed.
Okay.
Students deepen their understanding of waves and the anchor phenomenon through a series of multimodal investigations. They close read informational articles, use a rope to model waves, explore a digital interactive. They engage with SEP1 to ask questions and predict outcomes about cause and effect relationships. SEP3 to plan and carry out investigations on how different forces affect the materials. SEP6 to generate and compare multiple solutions based on how well they meet the criteria and constraints. And CCC2 as they test the effect of earthquakes on different building designs.
Graham crackers? Check. Trays?
Check.
What I want you to do is we're gonna take our twig books and we're gonna make predictions of how the force of compression will affect each of the 3 different materials on your tray.
Good. Let's get twisting.
Students continue to generate solutions as they consider how can our understanding of earthquakes and materials help us to build a safer future. Students consider key criteria and constraints for their designs as they look at SEP3, planning and carrying out investigations to test their design solutions.
Today we'll be starting our Engineer Design Challenge. You'll be designing an earthquake-proof structure. The criteria for success is a list of things that your structure must do. How will you know if your building is a success? How will you meet the criteria?
By using a ruler to measure how tall my straw is for the support beam, because for the criteria it has to be 30 centimeters tall or higher.
What materials would you choose for this and why?
The stick right here, because even though it's really thin, it's really hard. Even though the pasta is hard, the dried pasta, it can break easily, unlike this. I'm kind of worried like this for my floor, if it's gonna make it's too light and it might tip over.
Guys, can you propose a solution to Hannah's problem?
You could add whatever you're using for your stabilize. You could put some in the middle too, to hold it.
All that's left is to build and test. Throughout the module, students use the focus core ideas, SEPs, and CCCs with increasing sophistication to make sense of the anchor phenomenon and complete their design challenge.